Good evening everyone and welcome to the Q&A session 20 from the playlist of IIT-JEE Advanced Physics. The topic is the variation of electric field in the annular region of a charged cylindrical capacitor. So based on this topic, I have one question for this session which was asked in the IIT-JEE exam in the year 1996. So the question here is the magnitude of electric field in the annular region of a charged cylindrical capacitor is. So we have four options here. The first option that is that it is constant throughout. B, it varies as 1 by r. Here r is the radial distance from the axis of the cylindrical capacitor. And C is it varies as r. And the fourth option is that it is higher near the outer cylinder than near the inner cylinder. So here, in order to save the time, I have already drawn here one charged cylindrical capacitor, and the annular region is basically the region between the inner radius and the outer radius of the cylindrical capacitor. So here, this is the inner radius which is equal to A and the outer radius is equal to B. So the annular region is a region in which R is greater than A and less than B, where R is what? It is the distance of any point from, it is the distance of, or can say the radial distance of any point from the axis of the cylindrical capacitor. Now this point, in this case, or in the case of this annular region, will be lying between A and B. So, in the chapter of electric charges and field, and while studying the Gauss law, we have learned that the electric field due to a uniformly charged cylinder is equal to lambda upon 2 pi epsilon naught r, where r is the radial distance of a point from the axis of the cylinder, and from this equation, E is directly proportional to 1 by r, because lambda is the linear charge density which is constant, so and 2 pi epsilon naught is also constant. So from here we can see that the magnitude of the electric field is varying as 1 by r. Or we can, in other words, we can say that the magnitude of the electric field will decrease as I will move from the inner radius towards the outer radius. So thank you very much for joining this session. Now in the next session, I will be coming up with a different type of a question which has been asked in the JEE advanced examination, but the chapter will remain the same, that is electric charges and fields. So till then, have a nice day. Bye.